Now we're going to simplify fractional exponents. So whenever we talk about simplify, we're going to do it with one base first. So where the base is the same. Now what's going to happen is when you simplify it, you know you're done when you have a single base, single power, and no negative. I mean, it's going to be true because of the next thing. No negative exponents and you are in radical notation. So it's one base, one power, no negative exponents, radical notation. That's when you are done. So I think by this point we're on, I forget what example we're on now. We are on, we will say, was it 11? 11. So let's say you have the cube root of x times the fourth root of y. So the cube root of x times the fourth root of y. We can't really do much with radical notation, so we're going to turn to exponential notation first. So I'm going to say, okay, that's x to the third times x to the fourth. When the bases are the same and we multiply, we're going to add. So it's x to the 1/3 plus 1/4. How do I add those things? Common denominator it. So x to the 4/12 plus 3/12. Which means we have x to the 7/12. And then if we want to write that, it's going to be the 12th root of x to the 7. And that's our final answer. One base, one exponent, no negatives, radical notation. Okay, so we have a bit of a mush between radical and exponential notation, but that shouldn't be too much of a big deal. We should still be able to get the answer. So you may wonder what the root is over here, because there is no root given, but we have that root sign. If you don't see a root, of course, there's an invisible. There's an invisible 2 over there. If you don't see a root, it means there's an invisible second root. So we're going to write that as exponents. So it's going to be x to the 1/2, x to the 1/3, over x to the 2/3, which is going to be equal to, we'll kind of go down there. And the way we do this, when you have exponents like this, it's going to be x to the 1/2 plus x to the 3rd over x to the 2/3. Which is equal to, if we add these up, we get x to the 5/6 divided by x to the 2/3. When we have the same base but we're dividing, we subtract the exponents. So that's going to give us x to the 5/6 minus 2/3, which is x to the 5/6 minus 4/6, which is x to the 1/6, which we are going to write as the 6th root of x. So root x times the cube root of x divided by x to the 2/3 is the 6th root of x. We'll do one more of those. pen. Example 13. So the cube root of x to the 5 times the 4th root of x to the 7 is, so we're going to write it as exponents first. So that's going to be x to the 5 over 3 times x to the 7 over 4, which is going to add. So we're going to have x to the 5 over 3 plus 7 over 4. Common denominator is going to be 12, so we times this by 4. 20 over 12 plus 21 over 12. And x equals 41 over 12. And if we're going to write in pretty radical notation, it's going to be x to the 41 over 12. Now we do have to be careful about something. If we have, we'll do an example 14 here. So we have the 8th root of x times the eighth root of 3 to the x, of x cubed I mean. So that one is going to be equal to x to the 1 over 8, x to the 3 over 8, which is x to the 1 plus 8 plus 3 of 8, which is x to the 4 over 8, which we would write as, this is the 8th root of x to the 4. It looks good, and you're done, and you're satisfied with yourself. But that would be not quite correct. So this is not finished. Or not completely correct. What went wrong here? What went wrong here is, and this step over here, we actually could have reduced a fraction. And if you could reduce a fraction, even if it's in an exponent, you should. 4 over 8 is 1 over 12. And the way of writing that is, of course, root x. So the 8th root of x times the 8th root of x cubed is just the 8th root of x. And that's the answer.